Langton's ant is a two-dimensional cellular automaton governed by simple rules that produce complex emergent behavior. It consists of an ant moving on a grid of cells. Each cell is either white or black. The ant follows deterministic rules based on the color of the cell it occupies. The rules are: on a white cell, flip the cell to black, turn right, move forward one cell. On a black cell, flip the cell to white, turn left, move forward one cell. Why it is interesting? Because it demonstrates the emergence of order from chaos. There are two phases. Phase 1, chaos. For approximately 10,000 cycles, the ant's path appears random, creating irregular structures. Phase 2, order. After the chaotic phase, the ant suddenly starts building a highway, a repeating diagonal pattern that continues indefinitely. Let's take a look at the code. The HTML document creates a minimum layout with two main sections: a header containing interactive controls, a figure housing the canvas where simulation renders, key attributes. Autocomplete off prevents browser interference with input values. Min-max attributes enforce parameter boundaries. Inline styles ensure consistent control panel spacing. The internal CSS uses three selector types: universal selector, eliminates default margins paddings, sets box sizing border box for predictable sizing, ID-based layout wrapper, occupies full viewport, flex column stack for header plus canvas, type selectors header, figure, canvas. The header has a fixed height, 70 pixels, with centered flex items. Figure uses CSS grid to center the canvas. Canvas uses absolute positioning within a relative figure. JavaScript implementation. There are 6 core functions: initialization, initialize all, reads control values, cycle time, cell size, etc., calculates grid dimensions, row quantity, column quantity, creates a 2D cell array, cells, initialized to false, position ants, first ant centered, others random, calls render cells and render ants. 2 rendering functions: render cell functions, clear canvas, draws colored rectangles, light blue, dark slate gray, conditionally adds grid lines when the checkbox is checked. Render ants uses context save restore for isolated transformations. Positioned ant emoji with rotation math. Interpolates movement between cells. Update function handles the simulation state. Moves ant with edge wrapping, ternary operators. Flip cell colors. Updates rotation. Left-right are 90 degrees turns. Animate function. Uses request animation frame for smooth updates. Track elapsed time for consistent cycle timing. Event handling. A single input handler function handles any event present. Grid toggle bypasses reset, handled in render cells. Start button triggers request animation frame. Other controls call initialize all to reset the simulation. Key techniques implemented here. The structuring assignment. As you can see, I use it whenever possible. Double bitwise not operator, equivalent to math floor. Emoji positioning compensation. Rotation normalization. The link to the file location is in the description. I will scroll through the file now. That's all for now. Have a nice one.